So today we will start unknowns, solving for unknowns. And an unknown or a variable is just when you see a math problem like this and they give you a letter. Okay, so the letter is just a number. It could be any number. We don't know what it is. And it's important to understand that r will not always be the same number. So if you solve this problem and r is 3, it doesn't mean it's 3 on the next one. Okay, if you solve a problem and j is 2, the next problem, j could be 25. They just stand for a number we don't know. And I'm going to show you how to solve these problems. So today we're going to be working on just addition and subtraction with unknowns and with numbers that are around 10, smaller numbers, just so we can get the idea. So the first thing that you need to know is that in an equation or a math problem, the equal sign, okay, is where the problem has to balance. So here's my scale. Okay, it's like a seesaw, a teeter-totter, right? Whatever is on this side, R, has to be equal to what is on this side. Okay? It has to balance. So on this side, we have 6 minus 3. Well, we can do that, right? 6 minus 3 is 3. Okay? And for my seesaw, my scale, to balance, if this side is 3, this side also has to be 3. And R is all by itself. So what that means is that R equals 3. Because that is the value for R that balances that equation out. Okay, it makes it work. It looks a little funny because it starts with the number equals, but it's right. 3 equals 6 minus 3. That's true. 3 is the answer to 6 minus 3. Okay, let's do another one. So this one, okay, j minus 5 equals 1. So here's my seesaw. I'm going to balance it out. Okay, on this side, I have j minus 5. And on this side, I have 1. The 1 is all by itself, right? So if this side is 1, this side also has to be 1. So now I just have to think about how can I make something minus 5 equal 1? Well, if something minus 5 has to be 1, then this has to be 6. Because 6 minus 5 is 1. And now this works out. 6 minus 5 is 1. Okay? Here's another. 7 equals 10 minus s. Okay, so here's my seesaw. Equal sign. This side is 7. This side is 10 minus s. The 7 is all by itself. If this side is 7, this side has to be 7. Okay? So if 10 minus s has to make 7, what's s? 10 minus something is 7. It's like I had $10 in my pocket, I gave you some money, and now I have $7 in my pocket. How much money did I give you? The only number that makes that work is 3. So that means s equals 3. And over here, I forgot to write j equals 1 because the value, no, that's wrong. Jeez. J equaled 6 because that was the value of j that balanced my equation. If I make j a 6, 6 minus 5 is 1. That worked. If I make s a 3, 7 equals 10 minus 3, yep, that's true. Okay? Here's another example. 10 equals 7 plus n. Okay? Here's my seesaw. 10 is, here's my equal sign, right? This is like the equal sign right here in the middle. 10 is on this side. On the other side, it's 7 plus n. So let me just think about this, okay? 7 plus something makes 10. I have $7 in my pocket. You give me some money, and now I have 10. How much did you give me? The only number that makes that true, that makes that work, is 3. And that also means that both sides of my equation are 10. It's balanced, right? So n was 3. Okay? Here's another way to look at these. Same problems. I can also go through these same problems with parts in a whole, okay? So, if the seesaw makes sense to you, then use the seesaw. But if you're like, what? Maybe this will help, okay? Now, my parts in a whole, no matter how they write this problem, I'm really thinking either addition or subtraction, okay? It's either addition or subtraction. In a subtraction problem, you have to start with the big number. And by start, what I really mean is subtract from. So this is the big number because I'm subtracting from it. So it's 6, and my parts are r and 3. Okay, so if r and 3 have to make 6, then that means r has to equal 3 because 3 and 3 make 6. Okay, r has to be 3. Okay, here's another situation. Parts in a whole. I've got subtraction again. When you are subtracting, you subtract from the big number. So that means j is the big number. That means 5 and 1 have to be my parts, okay? When they give you the parts, add them. So 5 and 1 are my parts. Together, that's 6. J has to be 6. And then it's always a good idea to plug that back into your equation and see if it makes sense. If J was 6, 6 minus 5 is 1. That worked, okay? Okay, here we go. 10 minus s. It's a subtraction problem. Just because they put the answer over here, like, don't let that mess you up. It's just showing you that 7 is equal to 10 minus s. It doesn't matter what order they write it in, okay? Parts in a whole. Subtraction. We're subtracting. You have to subtract from the big number. 10 has to be the big number. That means my parts are 7 and s. If I know that I have to make 10 and I have 7, how much more do I need to get to 10? 8, 9, 10. I need 3 more. So s must equal 3. Because that balances out my equation. It makes both sides equal. It works. 7 equals 10 minus 3. Yeah, it does. Okay. 10, next problem. 10 equals 7 plus n. Okay, this is addition. This is addition. Anytime you do an addition problem, when you add the two numbers, you're going to make the total. You're going to make the big number. So when you've got addition, like I have, the two numbers that are being added will always be your parts. And that means this other number is my total. That's what addition does. It puts together parts and makes a total. Okay, so if 7 and n make 10, what is n? Same thing as it is here, right? 7, 8, 9, 10. 3. 7 and 3 makes 10. Okay, Let's go through just a couple more problems, okay? I'll wake up my computer here. Okay. 2 plus p equals n. 2 plus p equals n. 2 plus p equals n. Oh, that's impossible. You can't have two letters like that. Guys, it's getting late in the day. Okay, here we go. 9 equals 7 plus b. More numbers than letters, that's good. 9 equals 7 plus b. Okay, let's go back to the seesaw first, right? Here's my equal sign. It has to balance out. 9 on one side, 7 plus b on the other side. Okay, they have to be the same. They have to have the same value. So if this side's total is 9, because 9's all by itself, this side's total has to be 9. 7 plus b has to make 9. Well, if I have 7, what must b to get me to 9? 2, right? 7, 8, 9. b equals 2. And that would work. If I put it in there, that works. Okay, parts in a whole style. Okay, I'm adding. Anytime you're adding, you're going to be adding parts. I'm adding parts, I'm making the total. If 7 and b are my parts and they make 9, then I can figure out that b has to be 2 for that to work. For 7 plus something to be 9, something has to be 2. Okay? Okay. How about h equals 10 minus 3? H equals 10 minus 3. Okay. Seesaw. All right. H equals 10 minus 3. H is all by itself. Equals 10 minus 3. So I can figure out what 10 minus 3 is, right? 10 minus 3 is 7. So if this side of the equation is 7, this side of the equation has to also be 7. H equals 7. Okay? I can look at it this way. When you are subtracting, you have to subtract from the big number. You always, when you subtract, the big number goes on top and you take away from that. So 10 is my big number. If 10 is my big number, H and 3 are my parts. If H and 3 are my parts, okay, I have 3. How much more do I need to get to 10? That's going to be what H is. Well, 3 plus 7 is 10. So H is 7. Okay? Okay, I hope that helps.